Okay, here's what we're going to do today. I'm going to go over the problems from test 1, not the conceptual. Do you all know how to go look at your test? Because I can't show you because I'm not a student, so I don't have a test in my grade book. And if I go to my grade book, the teacher's grade book, it's all your grades. If you go to the grade book in Blackboard, click on the little arrow next to your grade and choose View Details, it'll come up a screen, choose View Attempt, and it'll go through and you can look at every question and it will show your answer and the correct answer. So you can look at every single one of them and review it. Now, that said, I'm going to go over the problems because, and the reason I'm not going over the conceptual is because there were like 80 conceptual questions and each of you got 25 of those and Blackboard chose them at random. So I can't go over that, but if you have a question about them, the problems, everybody got the same problems. Here we go. So those I'm going to go over. Okay, let me put this down. And then I'm going to lecture on the first part of chapter 5. Okay. Well, I got to put that somewhere else. Put that up there, I guess. And I like it a little bigger. There we go. Okay, Ajax, sales last year, 510. Operating costs, 362.5. Oh, Panopto, we're not doing anything. Interest charges, 12.5. What was the firm's TIE? There it is. They gave you the EBIT, they gave you the interest. You just divided. Okay. Alan and Sarah Winthrop are a married couple who file a joint return. 2 children, they have legitimate itemized deductions totaling $25,750. Total income from wages, $251,400. What was their marginal tax rate? Okay. That was their income. They got to deduct that. So that's what they actually paid tax on. And that was their tax, 25. What was their marginal tax rate? You looked at the table. During 2019, Bascom Bakery paid out $33,525 of common dividends. It ended the year with $215 of retained earnings. Prior year's retained earnings, $159,600. How much net income did they earn? Let me move to the right. Here's what you're trying to do. You're trying to fill in that block right there. If I have 159, I add something, I subtract 33,525, what'll get me to 215? 89,525. Okay, there's a whole bunch of them on, Koski. It's coming up here, a whole bunch of Koski. Current ratio, current assets divided by current liabilities. Quick ratio, current assets minus inventory divided by current liabilities. Inventory turnover, sales divided by inventory. TIE, EBIT divided by interest. ROA, net income divided by total assets. I have no idea why those aren't green. ROE, net income divided by total equity. Earnings per share, net income divided by shares. Price earnings ratio, price per share divided by earnings per share. Market to book, price per share divided by book value per share. I think everybody did pretty well on all of those. Okay. Hahn Corporation, sales last year, 425. Year-end receivables, 52.5. The firm sells on terms that call for customers to pay 30 days after the purchase, but some delay payment beyond day 30. On the average, how many days late do customers pay? Okay. You're trying to get the day sales outstanding. Well, sales per day was 1164.38. Day sales outstanding is end of year accounts receivable divided by sales per day. So if DSO is 4508 and they want people to pay in 30 days, they're paying 1508 or 09 late. Last year, whatever that name is, had 320 million of sales and 75 million of fixed assets that were being operated at 80% of capacity. How large could sales have been if they'd operated full capacity? 320 divided by 0.8. Fixed assets, you didn't need to know that. Last year, Harrington had sales of 325, net income 19,000. Year-end assets were 250. The firm's total debt to total capital ratio was 47.5. Firms finances using only debt and common equity. Total assets equal total invested capital. What's the ROE? Okay. Here's what they told you up here. If that's debt to capital, then that should be 1 minus. I'm going to put these things in. We'll correct it. There we go. Okay. If that's debt to capital, then that's equity to capital. So the equity dollars is equal to 52.5 times total assets, because they told you total assets equal total invested capital. Profit margin, they told you net income and sales. Total asset turnover, Microsoft Surface, go away. They told you sales and end of year assets. Equity multiplier, it is, where is it there? Total assets divided by net income, multiply the 3 together. You got it. Okay, 41. Meyer, total invested capital 670. Total debt outstanding 185. The new CFO wants to establish a total debt to total capital ratio of 55%. Size of the firm won't change. How much debt must the company add or subtract to achieve the target? Okay, if they want 55%, 55 of 670 is 368.5. They've got 185, so they need to add the difference. Precision Aviation has a profit margin of 7%, total asset turnover of 1.5, equity multiplier of 1.8. Just multiply the 3 together. That's their ROE. Preza's company balance sheet showed total current assets of 3,500, all of which were required in operations. Its current liabilities consisted of $975 of accounts payable, $600 of 6% short-term notes payable to the bank, and $250 in accrued wages and taxes. What's its net operating working capital? You don't need to know about the notes payable. There it is. It's 3,500 minus 975 minus 250. Whoops, sorry. River Corporation, total assets at the end of last year were 320,000, net income 32,750. What was its return on total assets? Just divide them. Royce Corporation, sales last year were 280, net income was 23,000. What's its profit margin? Again, just divide them. Vasudevand, whoever, where they get these names, recently reported operating income of 2.3 million, depreciation of 1.2 million, and had a tax rate of 25%. The firm's expenditures on fixed assets and net operating working capital totaled 0.6 million. How much was its free cash flow? Okay, there's your equation right there. I can up it a little bit. There's your equation. There. They told you EBIT. They told you the tax rate. They told you depreciation. And they told you the fixed assets thing. There you go. Okay, let me get it smaller again because I think I want to get out here. Okay, Woo Systems has the following balance sheet. Assume that all current assets are used in operations. How much net operating working capital does the firm have? Again, current assets. Let me get out here on the right. Just ignore notes payable. Like I said, they're going to put it in there for you. They're going to try to sucker you into using it. Okay, here's your AFN one. How did we do on this? Okay. DeSoto Corporation, sales are expected to increase from 6 million to 7.5. Its assets total 3.5 million at the end of 2020. They're at full capacity. Current liabilities are 1.1 million, 300,000 of accounts payable, 500 of notes payable, 300 accrued. Profit margins forecasted to be 5%. Retention ratio 40%. AFN. You had everything you needed. Change in sales 1.5 million. Total assets 3.5 million. So it's 3.5 million divided by 6 million times the 1.5 million. So we got that. Liabilities, again, just ignore the notes payable. You don't care anything about it. Accounts payable and accruals divided by current sales times the change in sales. 150. I don't know why it's not doing like it should. There we go. That's better. And profit margin was given. Retention ratio was given. That should say, I should pay more attention to what I'm doing here. Whoop. Whoop. That should be an S. And it's not S sub 0, it's S1. No, that was right. That was right before. One minus, oh, it should have been payout. That's what it should have been. There you go. 1 minus payout ratio. There you go. AFN 575. 49, whoops, too fast. Another one on cost key day sales outstanding. You had, and that should be AR. I put these things in here, so that's why there's arrows in it. Accounts receivable divided by sales divided by 365. You were given sales, you were given AR, 60.83. This last one, a lot of people missed this last one, and I suspect I know why. Last year, the company had $850 million of sales, 425 of fixed assets that were at 90%. What's the maximum sales growth rate the company could achieve before it had to increase its fixed assets? Well, if it's at 90%, then it could go to 850 divided by 0.9, which means it could add sales of 94.44 million. That's an increase of 9. Again, I got one too many in there. One too many little fours in there. You're dividing by the original sales, not by the 94. It's 94.44 divided by 850, 11.11 sales. Okay. Questions on anything? Now that's going to be in the recording. You can go back and look at your test and see which ones you missed. And if you have any questions about it, let me know. Okay. Going forward, all the tests look like this. They all have 25 conceptual. They all have 25 problems. The conceptual generally are random block, which means we won't go over them here, but the problems are all the same. So we will go over those after every test. Any questions about it? What we're doing, how we're going to do it? Okay, let's look at, give me the share thing. Chapter 5. I want to share my screen. Come on. Chapter 5. We're going to do chapter 5 in 2 parts because it's long. That would be one reason. From the beginning. Okay, this is time value of money. Chapter 5 and Chapter 7. We finished accounting review now. Chapter 5 and Chapter 7 should be the easiest ones because Chapter 5 is totally in your calculator. That's the good part. On the other side, everything else we're going to do in this class uses these techniques. So you've got to become so familiar with them that they're just second nature to you. There's no other way to put that. Okay, we're going to look at future value, present value, and finding I and N today. On Wednesday, we'll look at the other part of it, annuities, rates of return, and amortization. Okay, here's our basic definition. I, the interest rate. We call it a whole bunch of different things. Discount rate, cost of capital, opportunity cost of capital, required return, depending on how we're using it. Timelines. Think back to your stat class. Remember when they wanted you to draw the normal curve and shade in the part that's on the second line? That made it go away. And shade in. And I taught stat one time. I never could get students to do it. Normally, you don't need a timeline, but sometimes you do because it helps you visualize where the cash flows occur. Cash flow 0 right here is today. Cash flows occur at the end of the period. We always assume that in finance. They occur at the end. So cash flow 1 is occurring at the end of period 1. Now, there's a sign convention. When we're using CF, cash flow, I'm implying that these are not all the same dollar amount. They're different. If they were the same dollar amount, I'd use payment. If it's positive, it's an inflow to me. I have no idea what this is. They tried it just a few minutes ago. They're trying to fax something to a phone that's not a fax. If it's the positive cash flow, it's an inflow to you. You look at it as being relative to you. If it's an outflow, it's negative. Now, an inflow to you would be you borrow money, you get the money, that's an inflow. You invest money or put it in a bank account, that's an outflow from you. It's out of your hands. Okay, looking at a timeline, $100 lump sum that's going to be paid in 2 years. That's what it looks like on a timeline. A 3-year ordinary annuity. Notice the dollar amounts are the same for 3 years. Now, this is what we're going to actually deal with more in this class. It's the same number. It's the same number calling every time. Uneven cash flow stream, because we're going to be looking at business investments where the dollar amounts aren't going to be the same every time. That's how we're going to deal with them mostly. Here's your calculator. All we're going to do today for sure is those little gray keys. See them there in the red, the TVM keys. NIY, present value, payment, future value. First thing, either PV or FV must be negative. If you make them both positive, you'll get an error. Because in life, you cannot get money now, present value, and also get money in the future. It goes out now and you get it back in the future, or you get it now like a loan and pay it back in the future. One of them's got to be negative. Also, the interest rate is the same number again, is entered as a whole number. 5% is a 5, not 0.05. In your calculator, it's a whole number. In a formula and in Excel, it's a decimal, 0.05. Now, you need to clear the registers before you do a problem. And let me, I want to stop this share and pull something else. I want something else, but let me find it. Show them all. Well, where's my little calculator? No, I got it up here. Now, where is it? That's not what I want. I want my calculator. Well, hang on a minute and I will figure out where it is. USB drive. Now, let's see if I can share it. It's not letting me share it. It won't let me have. Are you seeing the calculator?
No, ma'am.
Well, hoot. I don't know how to make it share that. Because it's not showing it to me as a share. Ah, there it is. Okay. I got it now. Okay, there's the calculator. Okay, here's what you need to do. Let me put that down. To clear it, you want to clear the values in those 5 registers. Here's why. In your calculator, when you put a value in any of this, it stays there until you either clear it or overlay it. Well, you're not going to remember next time exactly what you did before, so you need to clear it. Now, with these, the easiest thing to do is just put something in 4 and solve for the 5th one. What we're going to do today is not going to use payment, so you just put a 0 in payment and leave it there. You can also say second and clear TVM, and it clears them all. I'll put that down. Now, I want to set the number of decimal places. Let me see if I can get my little guy back. Yeah, get my little guy back. Okay. 4 decimal places is a good number. It's enough to get you, because when you get a percentage, sometimes the percentage will be like 0.50. You want more decimals. Here's how you do it. Hit the second key and format. It's right down here at the bottom. See it? It's the second function above the period. It tells me I'm set to 4 decimals. Okay, suppose I want to change to 6. I press 6 I have to press enter to put it in, second, and quit. And now I've got 6 decimal places. It's going to stay that way. Even when you turn it off and turn it back on, it's going to stay that way. So I'm going to put it back to 4. Okay. Now, we're not going to get to do much with Excel, but there are Excel functions that exactly match those keys. N, I, Y, present value, payment, future value. And if you know Excel, all you have to hit is the FX icon. Okay, we're going to start by talking about future value. We always do. And your screen sharing is paused. Are you seeing the slide?
No, ma'am.
Oh, okay. Well, I've never tried using the little putting the calculator up before. Okay, there you should be seeing it now. Future value. We start with that because it's the most comfortable intuitively for everybody. If I put present value $100 in a bank account and I leave it for in years at this rate, I'll end up with that at the end. Everybody's comfortable with that idea. This is the periodic interest rate. This is the number of periods it's going to be in there. Now, probably none of you have ever used the future value tables because just about everybody does it on a calculator now. That's what's in the table, that right there, 1 plus I to the n. Note on your calculator, let me get my calculator back. Where'd my calculator go? Because I'm going to show you something real quick. See the 1 y to the x key right there? That's what that does. 1.05 y to the x raised to the 5 power. That's exactly what that key does. Okay, and I'm going to get my screen back. Okay, here's your question. What's the future value of an initial $100 after 3 years if the rate is 4%? It's called compounding. It's because you leave the money in there. Now you can solve it step by step. That's what you're looking at. I've got $100. It's going to grow. It's going to grow. It's going to grow. What am I going to have? After year 1, I'm going to have $104. The beauty of compounding is in the second year, I'm going to get that 4% on the 100 and the 4 and on the third year. And that's our general case right there. Now, everybody get your calculator and try that and see if you get it. Notice the $100 is negative because you invested it. And I'm going to share something. I'm going to get my calculator back. Where'd my old calculator go? Come here, baby. Here we go. Okay. In your calculator, N is 3. All you have to do is press 3 and just hit it. You'll know it's in there. Let me clear it a minute. You know it's in because when I press 3, it just says 3. But when I hit N, now it's got 4 decimal places. IY is 4. Same thing when I put it in. Present value is a negative 100. You do not do negative 100. You do 100 plus or minus, make it minus, and then put it in. Well, I want to move it, but I can't. Payment is 0. Compute future value. There it is. I got to get this thing someplace where it's out of my way. Okay. Everybody get it okay? This is how all of those 5 keys work. You put in 4, compute the 5th one. That's it. That's how you do it. Did anybody not get it?
How do you clear everything again right after this?
Well, I didn't have to because I put a 0 in payment. You can put second and clear work, second and above, second and future value. It's above the future value key.
Okay, thank you.
Okay. Here's how the relationships work. I do not actually anticipate that anybody will do this with your, you'll use the keys. But if you see the formula, then it makes sense. The longer the time period, the higher your value. Duh, if you leave your money in there longer, you're going to have more money. I mean, is that not fairly intuitive? If you get a higher interest rate, you're going to have more money because that factor is going to be bigger. You're going to multiply, your future value is going to be bigger. Okay, let's go to present value because we use present value a lot. It's the current value of future cash flows discounted back at an appropriate rate. You're trying to get everything back to times zero on the timeline. And it answers two important questions. This one is more a personal finance question. How much do I have to invest today to have some specific amount in the future? How much do I have to put in today in order to have so much for a new house, for my child's education, whatever? For us in corporate, it's more what's the current value of an amount to be received in the future. Now, why is it worth less? Well, opportunity cost. If you tell me I either have $100 right now or you'll pay me $100 in a year, if I have the 100 in my hands, I can invest it and it will be worth more than $100 in a year. That's opportunity. You promised me $100 in a year. That's uncertain. So bird in the hand is true. 100 in my hand is worth more than the promise of 100. That's where the discount rate comes from. What could I have done with it? How risky is it? Now, to get the present value equation, all you do is solve the future value equation around for present value. Now, remember, this future value divided by 1 plus I to the n, you can bring that up on the line and it's minus n. This is called discounting. It's the reverse of compounding. Have I been paused again? Are you not seeing this?
Yeah,
Yes,
we see the
ma'am.
calculator.
Okay. You all need to tell me. Did you see that?
We see the slideshows now.
Okay. I'll just scroll back through them. You all need to yell out at me when that happens because I forget that I have to go back to it. Okay, there you go. If you've got that, you can bring it up on the, make it a multiply by making the exponent negative. Okay. Okay, what's the present value of $100 due in 3 years if the discount rate is 4%? Okay, in this case, I'm going to discount it back. I could do it in my calculator. I could solve the general equation. And I'd get 8890. That's how you do it in your calculator. And I'm not going to stop and do it because it'll throw off our sharing. 1.04 y to the x3 equals, then you flip it over and multiply it times 100 and you get 8890. So you can do it without the TBM keys. Here it is in your calculator. Notice, this is negative, that's positive, this is going to be negative. The 100 you're going to receive in the future is positive. It's worth 8890 today. You could turn that around to say, well, if I invested 8890 today at 4% for 3 years, I'd have $100. One of them's got to be negative. Okay, here's your relationships on present value. The longer the time period, the lower the present value. Well, if you see the formula, it's obvious. If n is bigger, then this whole component is bigger. You're dividing by it, so present value is smaller. The logic is the further out in the future a cash flow is promised, the less it's worth today. The higher the interest rate, the smaller the present value. Same logic. This component will be bigger. You're dividing, so this is smaller. This is your opportunity cost. The higher rate I could have invested it if I had it in my hands, that reduces what it's worth today. There's our equation. It's got 4 parts. Your TVM keys, just put a 0 in payment. You know any 3, you solve for the 4th. Don't forget the sign convention. An inflow to you is positive. An outflow from you is negative. Now, that's not so critical right here, because payment is 0. So if you put, say, the present value is positive and it should have been negative, well, the future value will come up negative. The dollar amount will be right, but the sign will be wrong. The minute we get payment involved, that changes. It matters. Okay. If I've got 4 things here, we're assuming we're ignoring payment, I can solve for any one of them. I can find the implied interest rate right there. I bet you don't want to do that, but you can. You can do it with y to the x and 1 over the x keys. So you can do that. Just do it in your calculator. What annual rate would cause $100 to grow to $119.10 in 3 years? There it is. 100, 119.10. Solve for. Everybody try it in your calculator. I don't even have one here. Calculator. Now, I'm serious when I'm telling you, we are going to use this in everything we're going to do going forward. So it needs to be where you're just completely comfortable with this. It just doesn't take any time, any thought for you to do it. I will go, but remind me to go back. Somebody yell at me and make me go back. Okay. In 3 years, $100, no payment. It's going to grow to $119.10, I think it is. Future value. Compute IY. 5999. Whoop. Let's share my screen again. There I am. Okay. As I said, that's how those TVM keys work. All of them. The things you need to remember. With the TVM keys, you don't need to press enter to get the value in. Now we'll get my calculator back. I want to talk about something else. Give me something else. This is annoying because normally I could have both of them up on the screen at the same time. Okay. Remember when we were changing the format, I had to hit enter to make it go in. I don't have to here. Just 3 years, it's in. Negative $100. I just press the key, it goes in, and it's in. It's in. 119.10 goes in. Compute IY. And there it is. Stop that share and share that again. Okay. I'm getting better. Okay. You can solve for n in the same way. Turn the basic equation around. You can do that. There's an LM key on your calculator. Look over there on the left. It's to the left of the 7 on your calculator. So you could do this, but why would you? Because all you have to do is put in the values. Okay. There you go. If sales grow at 10%, how long before they double? Well, you don't have to know what they are. If they're 1 now and they're going to grow to 2, payment is 0, growing at 10%, how long will it take? 7.3. Okay, everybody do it in your calculator. I think we're getting close, but I might go on some. Okay, annuities. This is where we're going to start using the payment key, and it's going to matter. An annuity is a finite, these 3 things are important. It's finite. It has a time period. Equal payments. The dollar amount is the same every time. They occur at regular intervals, every month, every year, every whatever. An ordinary annuity follows the normal assumption in finance. The first payment occurs at the end of the period. An annuity due, the first payment occurs at the beginning of the period. That's not the norm. A perpetuity is an infinite series of equal payments. Well, we will see one because preferred stock is a perpetuity when we get to chapter 9. Okay, what's the difference? Ordinary annuity, there they go, little payments. Annuity due. Everything just occurs 1 period sooner. Perpetuity, there's the formula for it. Now, in my wildest dreams, I do not assume that you're going to use these formulas, but I'm showing them to you for a reason. There's the formula for the future value of an ordinary annuity, the present value of an ordinary annuity. You certainly could use them. There's the formula for an annuity due. Okay, look at it. That's the difference. This is going to be important when we talk about how to solve this, because there's a couple of ways to do it, one of which is better than the other for us. Better. You just solve for an ordinary annuity like you normally would and multiply the result times 1 plus the interest rate, and you've got the annuity due. Now, the payment key, this is where we're going to use it for the equal payment. The sign convention is important now. Now, here's what I'm not overwhelmed with you doing. Your calculator will handle an annuity due, but you have to switch it yourself. And most problems are ordinary annuities. And here's how it's going to tell you how to do it. We'll put it out. Whoop. I want to put it up there, and then I want to get the calculator. I want the calculator back. And I'm going to show you how it works. Notice up there at the right-hand corner in your calculator, there's nothing right now. That's end mode. If you hit second.
Sorry, I couldn't hear what you said.
I have no idea what that was. Anyway, there's nothing up there. Hit second and the payment key, which the second function is begin. It's telling you right now it's set to end. That's the norm. This is a toggle. Look at the screen, sis. Press second and set, and it changes to begin. It's now set to an annuity due. And look at the little BGN up there in the corner. If I quit right now, that BGN stays up there. Now, that's great. Suppose you work in an environment where you are always dealing with annuities due. This would be great to be able to set it and just leave it. I'm telling you right now, on a test, I can just tell you already what'll happen. You'll change it and you'll forget it and you'll leave it there. I've seen it too many times. So we're going to look at another way to do this. I want to set it back to end. That down, and I want to share something else on PowerPoint. There we go. Okay. Now, the annuity payment, the payment goes in PMT. If you were using Excel, there's a type out there at the end. The default is 0, so you don't have to put it in. If it's an annuity due, you put in a 1. That's what signifies it. Now, here's an important thing to remember. The interest rate, the time period, and the payment period have to match. If it's annual payments, then the rate has to be an annual rate, and the period in has to be years. If it's monthly, they all have to be monthly. And the sign convention is important. This is an example. I gave this problem on a test years ago, and a really good student got it wrong. And I was looking at it thinking, how on the earth could they have missed this? You'll see. On the left, implies you deposited $100 because the 100 is negative. That's a deposit away from you. And you withdrew $20 a year for 5 years because that's positive. Positive is inflow to you. The question was this. This says that you deposited 100 and added $20 to it every year for 5 years. Here's the point. The answer is completely different. It's not just a sign. The actual answer is totally different. So you have to be careful about the sign convention when you've got payment involved. Okay. 3-year ordinary annuity, $100 at 4%. Payments occur at the end of the period. There's no present value. If they don't tell you in the problem something like, right now I've got $1,000 in my account and I'm going to add 100 to it, then present value is 0. Okay, everybody try that one. guess I tried. Everybody get it okay?
Yes, ma'am.
Good. Okay. In this case, 100 payments, there's no future value. What you're wanting, what the question would be here is, how much do I have to deposit right now to withdraw $100 a year for 3 years if I can earn 4% interest? $277.51. You want to draw it down to 0. So there's no future value. Keep on trying them. I want it to become so second nature to you, using those keys, that you don't even think about it. You just do it. Because you're going to do it a lot. A lot. Okay. Okay. Suppose the payment's future value occurs at the beginning of the period. All you have to do, we got that 312.16, just multiply by 1.04 and you get the 324.65. Much safer, because you haven't changed a setting in your calculator. Or you can set it to begin. You'll get the 324.65, but you've got to remember to set it back to end again. And like I say, I've just seen that happen too many times on a test where it didn't get set back. Okay, same thing for present value. It works either way. We got the 277.51, multiply it by 1.04, and you get 288.61. Same thing, set it to begin. Okay, what's the present value of a 5-year, $100 ordinary annuity at 4%? Notice they're telling you right there, be sure to set back to end. Okay, y'all go do that one. Go do it. We're going to do a bunch of problems too on Wednesday when we finish up the chapter. Oops, back up. Okay. 5-year annuity. 10-year annuity, it's worth $811.09. 25-year, 15. Perpetuities, $2,500. Now, this is a good one that they stick in here. A 20-year-old student wants to save $5 a day for her retirement. So every day she puts $5 in a drawer. And at the end of the year, she invests the accumulated savings, $1,825, in a brokerage account with an expected annual return of 8%. I'd like to know where she's doing that. How much money will she have when she's 65? There it is. If she sticks to her plan, she'll have $700,000. 45 years, she's 20 now. She's getting 8%. She's not starting with anything, but she's putting $1,825 in every year. She'll have $700,000. Not shabby. If you don't start saving until you're 40 years old, how much would you have? $133,000. The key is it pays to start saving early. The difference there, over $500,000 difference. How much would a 40-year-old have to deposit annually to catch up? Almost $10,000 a year, because they're starting late. So that's kind of a little personal finance thing that they stick in here. Okay, that's the end of part 1. Let me stop the share there. Okay, here's what I want y'all to do. On Wednesday, we're going to go part 2, which is the rest of chapter 5, and we're going to look at the problems, some of the assigned problems. You need to go work on them and be sure you're comfortable with your calculator, because I assure you we are going to use it for everything. We're going to use it in chapter 7, valuing a bond, chapter 8, valuing risk and return, chapter 9, valuing stock, and most assuredly, chapter 11, when we do net present value. So you need to be real comfortable with it. So I want to stop now because I want you to go and do that. go and do anything in MindTap that's going to get you comfortable with this. Do you have questions about it? We know what we're up to. I look sleepy today. Everybody quiet? Do you like that so I can see everybody? Oh, see, y'all are being sneaky. Only a couple of you are really up there. Okay, any questions on anything? Any questions on chapter 5? Everybody got a calculator? Everybody got a calculator? If you don't have it, you need to get it. Go get it, because we're going to use it for everything. Okay, that's it. I will see you on Wednesday at 4:30. We will do the rest of chapter 5. The whole thing is out there, so you can see the whole thing. Chapter 5, and we will look at some of the end of chapter problems. Okay?
All right. Have a good one.
You too.
Thank you. Later.